we are going to see solar radiation, Sun-Earth relationship. The Sun is about 1.1 10 power 11 meter away from the Earth. So, thermal radiation travels with the speed of light in a vacuum 3 lakh km per second. After leaving the Sun, solar energy reaches the Earth in 8 minutes 20 seconds. The electromagnetic radiation. The Sun's radiation is electromagnetic radiation. The wavelength is distance between successive crest or trough in terms of kilometer, meter, millimeter, micrometer. And another term, frequency, wave crest per time, unit second, that is cycles per second or hertz. Longer wavelength has lower frequency, which is inversely proportional. The frequency is inversely proportional to wavelength. So, higher the frequency, shorter the wavelength. So, when we multiply the wavelength and frequency, we will have velocity of wave. Electromagnetic radiation has certain properties. It can travel through space in a vacuum, travel at a speed of light. It can pass through liquid, solid, gas. Electromagnetic radiation can be refracted when crossing different medium as well as observed. Solar radiation arrives on Earth primarily as visible and ultraviolet and is reflected and observed, radiated to space as visible and infrared. The Sun's electromagnetic spectrum. The radiation intensities varies and corresponding to the wavelength. The solar radiation has peak intensity in shorter wavelength and dominant in the region we know as visible, thus short wavelength, short radiation. Long wave and short wave radiation. Hot sun radiates at the shorter wavelength, carries more energy, and fraction observed by the cooler Earth is then radiated at a longer wavelength. Certain amount of radiation has been observed by the top of the atmosphere. Solar radiation incident on the Earth's surface. The incident radiation is constant, but the radiation at the Earth's surface varies widely due to atmospheric effect, including absorption, scattering, local variation in the atmosphere such as water vapor, clouds, pollution. It varies due to latitude of the location and season of the year, time of the day. The radiation has certain laws. The perfect radiator is black body. Black body at a constant temperature absorbs all radiation and it can emit all radiation what it has absorbed. All object emits and absorbs all forms of electromagnetic radiation. The lambda, the most intense radiation emitted by the black body, is inversely proportional to absolute temperature of the object. Wavelength is inversely proportional to temperature. Here the C is a constant. 2897. Lambda is in terms of micrometer, T in terms of Kelvin. This statement is Beer's displacement law. The hot object emits radiation at a short wavelength. The black body is the sun emits 600 Kelvin. The temperature is about 0.5 micrometer. The cold object like planets, Earth atmosphere emits radiation at a longer wavelength. Black body temperature is at 50 degrees centigrade, about 10 micrometer. Stephen Boltzmann law. This law, total energy flux emitted by the black body across all wavelengths, is proportional to 4th power of absolute temperature of the object. A small change in the temperature results in a greater change in the radiation. Since Earth radiates at a greater temperature than Earth, the law predicts that energy output per square meter of the sun will be 1,90,000 times greater than Earth. This is another law. The inverse square law states that radiant energy is reduced in proportion to the inverse square of the distance from the source. The source is considered as the sun. As the distance prolongs, the radiation gets diverged so that the energy also reduced in proportion. The intensity varies according to the latitude of the Earth. This shows that when sun is overhead, the intensity is more. Then sunrise and sunset, the intensity will be less. This is Lucent, this is Eisen. The solar intensity is defined as the energy per area is different at different altitude. Sunlight beam strikes at an angle is spread across greater surface area and is low intense heat source than a beam impinging directly. When the North Pole receives, the radiation spreads over large area. Here, the equator radiation focused on small area. Radiation spreads over large area in South Pole also. Pole to equator heating balance. The equator receives more amount of energy. North Pole and South Pole receives low amount of energy. Some amount of energy has been absorbed in the Earth's surface. Some amount has been reflected by the clouds. Some amount has been reflected by the Earth's surface. Here the reflection due to the South Pole and North Pole is more due to the ice present in the South Pole and North Pole. The Earth annual energy balance. The balance means here there will be a more amount of solar energy present. Here the low amount of solar energy present. So the heat will try to transfer from high to low temperature. The global balance is maintained by excess heat from the equatorial transferring towards south. The incoming solar radiation has been reflected by the space, atmosphere, and has been absorbed in the atmosphere, as has been observed in the X-surface also. These are all the percentage. 31% has been reflected by the space, 4% by the atmosphere, and 17.5% has been observed by the atmosphere, 47.5% observed by the X-surface. The observed radiation has been radiated to the space. Certain amount of radiation has been observed by the atmosphere. At a point of time, certain things are medium to space. Global solar radiation budget. Here the reflected radiation is 31%. Observed radiation is 20%. Observed by the sun's Earth's surface 49%. The climate is controlled by greenhouse effect. That is, greenhouse gases present in the atmosphere, namely water vapor, CO2, ozone, methane, nitrogen oxide. The percentage of infrared radiation observed varies with the wavelength. The atmospheric window is range over little or more radiation is observed. The visible window is the extent up to 0.3 to 0.9 micrometer. The major infrared radiation 8 to 13 micrometer. The peak infrared radiation emission of the planet is 10 micrometer. Solar radiation. The atmospheric effect. The solar radiations are observed, scattered, reflected by the compound of the atmosphere. The radiation reaching the sun is less than what entered from the top of the atmosphere. We classify that radiation in two categories. Direct radiation. The radiation directly from the sun reaches the earth surface through scattering. Is direct radiation. The diffuse radiation is radiation that is scattered by the atmosphere